Computer, generate 8-foot-tall Futanari versions of Bryce Dallas Howard and Eva Green. Reprogram to give them severe maternal instincts, but make them think that having sex with someone is the same as protecting them. Alter their perception to make them think that I am their son. Disengage safety protocols and run program.
Sir, we don't have a holodeck. This is a storage cupboard.
Welcome, everybody. We don't have a holodeck. This is a storage cupboard. So whatever your sick, twisted, perverted minds are thinking, I suggest just keep it in your mind until we get the holodeck. Welcome in, Greg.
Boom. Hi. I didn't realize I was still on mute and not show your face. I was picking out this this awesome photo of my dog, one of my dogs, as my avatar here. So
see that right there. 150,000 subscribers right there just for the dog.
Oh yeah, if we just had Thor and Loki on here to do the show for us all one day, it would just be like, well, I mean, probably a mess, but probably more subscribers because they're adorable. Far prettier than I.
Well, welcome in, everybody. This is Silver Linings 21. Wow, we're going right through this. So, yep. And I think the intro kind of makes the point of what we're going to discuss out of paper 4, because there's something unique about it. There's something unique about that intro and how comical it can be, but just how human beings kind of are active and reactive to certain aspects of life.
It's almost as if the entirety of the effort is a pressure system, right? And that really what it's about is stabilizing an unstable state into something that we can call metastability.
Or in essence, trying to set up a holodeck for sexual pleasure.
Well, it's natural implications of human civilization extended into Star Trek, isn't it?
Episode 2 of season 1.
Yep. I mean, you can't help it. Once you get the technologies they have in place, somebody has to come up with that one. It's almost forced.
Oh,
it's an interesting point about the pressure system that is civilization, right?
It's inevitable, especially when you start going into the holodeck and assigning yourself into a nightlife bar from the 1950s.
Right. I don't understand how holodeck isn't just like civilization in Star Trek. That's the one thing, like, why even go to the stars in to a certain degree? Because if you can visualize something that perfectly, you're not living in a simulation of it. You're there, right? That's one of the neat things about the chronotopological point of view, is that limited bandwidth suggests that simulacra and simulation are confusing, not because one is a slightly modified recursion on the other, but because there's not enough universe, there's not enough bandwidth in it to have perfect simulations be any different from the space itself.
Yeah. Well, that's what the brilliance of what my favorite is, The Next Generation, obviously, not just because it's the second the second series, the first full series. I think it's just better. But because where they had it to what they could do, even in the late 80s, being able to do more production wise than they could back in the late 60s with the first one, and even with the early movies of the original series, they actually ended up implementing the idea of the holodeck with Next Gen. And honestly, I remember when you watch Star Trek Next Generation, they had many episodes, many episodic arcs for the story that implied being in the holodeck. So
yeah, I mean, and what's interesting to me too is they've never wired a holodeck out to the controls of the ship. So if I was going to design the ultimate universe taken over a Star Trek vessel, it would be the core of the ship, all the engineering stuff, everything built to be maintained by, I don't know, a very tiny, robust little robot, like a quadruped robot. I'd plug my crew and my captain into the holodeck at the very center of the ship where they're most protected in a very shielded shell. And I would simulate the existence of the ship in the sense that you were inhabiting it comfortably while you piloted it and fought and did whatever, right? Explored. Such that the whole time you were running the thing, you were actually living in a holodeck sim. It would make it easier to build a ship that was robust against attack. You know, you could load all the crew quarters up with weapons blisters instead of crew quarters, and have a ship that could make even the Borg think twice about attacking.
Resistance is futile, everybody. We're coming up with ideas.
Yeah, also the Borg running around in like a physical robot world doesn't make sense in a holodeck land either. Like all those people would just be plugged into a big sim, appearing however they wanted to, you know?
It'd be like the Matrix. You just plugged into the Matrix.
Exactly. Except for exactly like the Matrix. They even in the Matrix, the third one, they even had a scene where exactly what I was suggesting was happening. Like remember they were flying up to the gates of Zion for the first time, and that woman's like, doors open, beds made, and they're sitting in that completely white blank space with these perfect float screens in this otherwise filthy city. Yeah, they were jacked into the control system and it was wired back into the world. The sim was controlling real life. That's the difference between the Matrix and your human body, really, when it comes down to it.
So, Greg, you have a pie.
We should jump on into to some of the implications of paper 4, I believe, because this is where paper 3 starts to make some sense, where the rubber meets the road, so to speak.
I think that's what we should do. We should just dive right into it. But I have questions that hopefully this paper will answer. Because when it comes down to it, what if what we know as plausible action and relevance to our realized potential isn't what it is perceived? What if physics cannot portray the fullness of the unique in a universe that is built as a structural perfection? What if we must be the one who stimulates or admits, going from the paper, you'll see that, everybody, the cause to an eventual act?
Well, so as it turns out, you're exactly right. That, at least in terms of the math, in order for the system to balance, i.e. for the math to close, for the universe to exist, at some point, intelligent agents asking those exact questions are a necessary consequence of the existence of it. If they didn't emerge, the system would never stabilize. Right? The universe exists, but it would not be able to exist as it is without intelligent agents like us asking the questions we're asking in it, which is kind of the neat part, right? Literally, you need agents. They're an emergent consequence of the way the setup begins. Right? Causal order plus distinguishability kind of requires it in finite bandwidth world, because after a while, the balance between the finite and the infinite has to be maintained. Like actively. Otherwise it ends, right? Like you don't add future possibility anyway. Imagine if there were no people on Earth, no animals, no animals on any planet, no life, nothing green, nothing moving, just the whole universe stops at the edge of chemistry and goes no further.
Yeah.
Eventually all the chemical equations would balance and you'd have nothing but dead rocks flying around bright stars. That would be the way it ended.
Yeah.
It would go no further.
Yeah.
And yet the counter local force pushes closure. So even those things would end if nobody built them into structures, right? Like if you didn't have anybody gardening in the garden, it would decay.
And it does.
Yep, it does decay. For where humans are paying attention to it, or animals are paying attention to it, or plants are paying attention to it, because plants have a sort of attention when you think about it. Rock becomes dirt because roots grind it up, and then the plants that had to exist to grind roots, right? They couldn't live in that soil anymore, or grind rock. They couldn't live in that soil anymore because it was too rich with minerals, right? Human beings come along and plant in it, pulling those minerals into the plants, or birds fly over and poop plant seeds into the soil, right? The universe continues because life and agency and intelligence exist. Otherwise, it would just be a dead, cold nothing flying around, nothing of interest, nothing of value. Eventually, it would decay, come to a halt, and that would be the end. But then the math wouldn't work, because the math that we've uncovered says nothing ends.
So what you're saying is uniqueness is paramount to all of us in an entirely expanded universal causal order?
Yes, I would say so. And I would also say that while the deists were wrong about the clockworkiness of it, they got really close to the idea that the universe couldn't exist without, or creation couldn't exist without us in it, which is an interesting and kind of counter to the tradition of science these days with respect to how it perceives man, kind of conclusion, right? It's not that humans had to be the ones, but something like humans had to exist. Otherwise, the universe wouldn't exist.
This is one that might get some pushback, so clip this. Is it good to say that the evolutionary theory that has been established makes sense towards the progress of all life on this planet, and even the universe for that matter, though we haven't extended that far to truly understand, but it doesn't apply to humanity?
Well, I don't know. I think that it might be the machine meant to make us come into being.
Because that's what and that's what I look at. Like, you get, whether you're arguing on an anti-evolution, not really anti, because there is an evolutionary component to the physics and the chemistry and the structures of the planet and of the universe, obviously. But when you pull different side pieces together, whether it's within faith, whether it's within the scientific, the pseudo-scientific theory of like the ancient astronaut theory, there's always something that corresponds humanity as a bridge that was just formed essentially out of nothing, but always out of something within that nothing. But everything else has where they appear and evolve into certain adaptations. We aren't adapting like a more natural selective type of duration. We adapt because of how we're kind of like, it's ingrained in our soul and in our brain of how we need to like manipulate certain things within the life that we live, within the earth that we're living, so that we can survive. So like, we make our adaptation while every other creature on this planet ends up evolving generationally, genetically, in order to continue to adapt. So like,
with a few exceptions, right? Dolphins and whales will actually pass culture and learnings about, like, there's that one killer whale pod that or orc whale, whatever you want to call them, pod that figured out that if you go to this particular area and you swim in just this particular way, you can corner a bunch of fish against a beach. It's this one harbor, one time a year, where this particular type of fish is blossoming into lots more of those little fish. They're spawning, and these whales will figured this out, and then they pass it on. And then the next year, more pods started showing up and doing the same thing. They continued to teach others how to find the place, right? Just because we can't hear the way sound travels underwater the same way those kinds of animals do, doesn't mean that they don't have rich communication going on, right? Maybe it's just that humans fill a particular niche of biological intelligence in an air, like a land, air, oxygen, nitrogen phase, whereas a land, air, water, nitrogen, oxygen phase plus more gravity, plus more pressure around you, gets you dolphins and whales, right, in that niche instead, swimming around, curating their environment rather than being subject to it. It's perfectly in line with the notion that maybe when we look at the stars and say, where is everyone, like Enrico Fermi did at that lunch that got us Fermi's paradox way back in the day. Where is everybody? You know, if the universe is full of life, why hasn't anybody messaged us yet? Well, as it turns out, the problem is the message bandwidth, not the plausibility of life existing. It may very well be that when you look up at those stars, every one of them has a civilization in it.
And they're probably, and maybe they're doing the same thing, looking up on their
and
planet.
wondering where everybody is.
Yeah, where is everybody?
Right.
You
Like,
never know.
when you think about the wow signal, especially in a chronotopological frame, right? Like the amount of coordinated structure sitting behind that for such a signal to break through the cosmic background from so far away would have been immense. It was almost like someone saying, yes, there's a civilization here, because it would take a civilization to send a message that cut through like that. And it might have been one of the most advanced civilizations we've ever encountered, right? Because to send a message that cuts through that cosmic background, you start trying to figure out the energies involved. You know, someone's harvesting a star, right? At least one star, maybe more.
Yeah.
And there are very few other plausible explanations for that one little signal. Have you guys, do you think everybody's heard of the wow signal in here?
I don't know.
We should show a wow signal blip real fast here. Let me see if I can find like a picture of it.
Well, you find that. Speaking of wowing, and speaking of sending out signals to figure out if anybody's out there, Andrew is not with us today. He sleeps peacefully. So, in order to wake him up, why don't you hit that thumbs up, subscribe, and ring that bell for more. All for Andrew.
See if I can find it. Yeah, you know what? I'm just going to go ahead and pull up this and send it to... Actually, Zach, if you just open the Wikipedia page and share that screen, there's like some good images on there. There's not much on Wikipedia that's any good besides the imagery sometimes, but...
What's it called? The wow?
WOW signal.
Oh, yes.
There's an exclamation point after wow. Now, the reason they call it the wow signal is because the person on staff who was monitoring the ticker tape from the SETI project when that emerged circled it and wrote wow, and that was the moment. And by the time they'd had anybody else come in to start verifying it, right, the signal had already passed. It was a very short signal. Yeah, so pull that image up. See the original. That sequence right there represents an above. So those numbers and letters, what you're looking at is hexadecimals, right? Signal strengths occurring across a graph. So we went from 6 to E to Q to U to J back down to 5.
And
right?
what's the relevance of the letters to the numbers?
So yeah, that's hexadecimal. So you know how you count to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's base 10 math.
Yeah.
Right? And the reason it's base 10 math is because once you get to 10, you roll over to a new decimal place, right? There's nothing, there's no number past 10 to go to. Or rather 10 is like the time, you know, you get a denominator shift. You get to 9, you roll over to 10 when you add one more. Hexadecimals roll over at 16 and continue to count up all the way to, I think, Q or U.
Okay.
Exactly. I'm not counting right, but you see what I'm saying, right? Hexadecimals mean 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right on up until you get to base 16, right? So when you add 1 to E, you get F in base 10 instead of and when you get all the way to the top of base 16, right? Hexadecimal, this means 16 decimal, right? Or 16 plus decimal, hexadecimal, right? Whatever. I'm not exactly going to translate that, but Binary is another base. It's base 2. You add 1 to 0, and you get 1. You add 1 to 1, you get 0, 1 in binary. So anyway, that's what you were looking at there. So there's the other thing we're pulling up is if you can find out where the signal came from in the star chart. You guys can't hear my dog barking, can y'all?
Oh, we can hear him.
Ah, damn.
Okay. What about this one then?
That one. That's the one. Zoom on in there. That's the region where that signal likely came from. And is it showing? Can we zoom in on that closer?
Mm-hmm.
Right. I'm not even sure where we are in all that. Are you?
I have no clue. All I know is it looks like constellations.
Well, the point being, see those little dots, right? Those are stars, right? We can all tell that. This region is that big. That's how far away that signal had to come. That's how wide the band of it had become by the time it reached here. Because you ever shine a flashlight real close in it and then pull it back, right? That's the same effect of a broadcast out into the stars, right? So they sent something that came to a point somewhere in that region, given what we can tell from where we are. So wherever the apparatus that sent that signal is, it's in there. Whether it's a weird pattern of exploding stars that happen to daisy chain, or a weird pattern from some kind of machinery, or a weird pattern of some kind of machinery that exploded stars in order to send that signal in just the right sequence. Like, we don't know, but the neat thing about it is it cut through the band limit so much that we could catch it all the way here on Earth. Which suggests to me an immense amount of organization behind the effort.
Anyway. And that organization could be divine. It could be other beings. It could be a combination. That was a weird. Yeah,
or we can find that there is no distinction between any of those things at all to begin with.
Exactly. So. It could be me doing all this.
Right.
See, we're no longer on the screen.
Yeah, it could be the sound a civilization makes when the last person finally gets on the internet.
The last person to get on the internet means that they're the last person on Earth.
Yep. It's also what happens when you burp, fart, and sneeze at the same time.
I heard, actually, and all joking aside on it, because it is kind of a joke, but seriously, if you burp, fart, and sneeze, I need this answered. I need this answered. Does it kill you?
Oh, it can't. There's no way. You just have a lot of continuation pressure you need to evacuate all of a sudden.
I've heard it probably more jokingly, more so than
no.
anything.
If you sneeze and hiccup at the wrong time while also throwing up, you could die.
What is the relevance to that?
Well, it's a vent of pressure that you didn't really necessarily have control over.
But whereas like a burp and a fart and a sneeze is that pressure build up from head to intestines, and that's actually a good thing to release gas.
It's a high energy discharge into a lower dissipation exhaust state, right? Which we will learn more as we go through further into the papers, how the universe kind of requires that pressure system to balance.
Well, everybody, should we go deep? Should we get into it? Should we get into paper 4?
Let's do it. I could use some Dr. Manhattan-ish voice right about now in my life.
The action of uniqueness, closure, ledger, structure, and the physical projection.
You read that with an of, but it's actually action uniqueness.
Oh, action uniqueness? Yeah.
Yep, action uniqueness. So the uniqueness of the action. So in physics, right, like cosmology, theory of everything physics, right?
Mm-hmm.
The action describes traditionally something that people call the result, or sort of the dynamic result of perturbations, right? So you set up a model, you perturb it by making sort of like little changes across the entire surface using statistical math, right? What happens if you vibrate the state? And then the action is what processes those state changes. And the theory was always, if we get the action right, then perturbation, the setup and the action right, then the perturbation should recreate the effects we see in physics.
Mm-hmm.
Right. And then we'll know we've gotten closer to a physical system that matches the physical projection that we see. Right. And when I say the projection, what I mean is, under our finite limited bandwidth, our visibility, our audibility, or our audition, our vision, our taste, our smell, our sense of feel, right? That sensorium in a brain this size can perceive not the universe, right, but a physical projection of it. We have to flatten it into something that's small enough for us to observe. Now, the interesting thing is that all of physics presumed that the open space around what we could see was full of stuff, right? The interesting thing about what chronotopology has figured out is that the universe doesn't support stuff we can't see.
Mm-hmm.
Like, if we can't detect it, there's no unknown imaginary that we can't detect, because the universe doesn't support stuff like that. If it were there, we would be able to see it. That's the interesting thing.
Mm-hmm. That is interesting.
Not necessarily see it, right? Like sense it, detect it, using some device, detect it. And that's when I say see it, understand it through empirical observation of some sort, to measure it. If it's measurable, it exists. And if it's not measurable, it doesn't, is what chronotopology says.
Like using a frequency capable telescope that looks further out into the universe, more, I guess, on more of an auditory level within the frequency mechanisms, that is much more expansive, rather than just using
Optical.
something that expands the eye. Because even through our eyes can only see what's in front of our face. So all we're doing with a visual aspect, when we're not focusing on a frequency aspect, it's just extending our eyes so we can see further out, but then there's still a limitation. Whereas
the speed of light limitation there, right? Or it's not really the speed of light so much as it's the the least costly path that a photon-like emission, light, right, can follow, right? And at the rate that it can move without violating the conditions, the energy of the conditions that generated it, right? The best it can do to sort of balance the books of its creation is go at a straight line, along a geodesic, a straight line usually, but curved sometimes by what we typically call gravity. But now I don't want to get too far ahead of ourselves and start talking about gravity before we've got the baseline. So let me just stop there and let the video take over.
Let's let the video take over.
Paper 4, a spoken word guide.
A real quick pause.
Action, uniqueness.
Yes.
You can tell probably over time that the sound quality and the video quality is getting better. By the time we're through 10, it's really perfected. There may still be some sound blips, but right now, this will be the first one I started using a clean up on the audio filter, so the sound should be better going forward from here.
All right. You heard it from the master, everybody.
Closure, ledger structure, and the physical projection. Part 1. What this paper is really about. Paper 4 asks a dangerous question. If chronotopology is right, what becomes of action? Not in the everyday sense of doing something, in the deep physical sense. What becomes of the thing physics usually treats as central? The action, the object you vary, the thing from which equations of motion are supposed to fall. Paper 4 answers with a correction. The action is real, but it is not what most people think it is. It does not generate admissible motion. It records the closure cost of motion, whose admissibility is determined elsewhere. That is the paper's central reversal, and it is a very deep one. Part 2. The classical problem. In ordinary physics, one often says, the action tells the system what path to take. That phrasing is so familiar that it stops sounding strange. But from inside chronotopology, it is backwards. Paper 4 insists on the correction. Admissible motion is governed by continuation geometry, not by the action. The action evaluates the cost of a realized path. It is a ledger, not a primitive engine. This is the same general move Paper 0 makes about language. A familiar phrase hides the wrong ontology. Paper 4 strips that away. Part 3. The setting. The paper works in a very specific regime, a four-dimensional manifold-like causal set. That
Okay, let's pause
specificity
here.
matters.
All right.
I feel like we ought to tell people what a four-dimensional manifold like causal set is before we move forward, because it's kind of a weird concept. So the idea is this: we're going to build a graph using a machine, and the graph is going to represent, like, each node on the graph, each plot, each point is going to represent a node in a synchronized cluster, right? A synchronized cluster is a set of events that we can attribute to a cause-effect chain. Really simple, right? You tip over a domino, your causal chain is the domino rally that follows, right? But if you had two domino rallies, one sitting side by side to the one you're hitting and one out of arm's reach, you would need two people to trigger them concurrently such that they were running at the same time. Exactly, right? You'd have to time it. You'd have to synchronize. Thus, you would synchronize the two clusters together, right, with a separate synchronized cluster, make them causally linked. And so you can start to picture what a synchronized cluster is. It's weirder at the beginning of the universe, right? Because what is an event? What does it do, right? What's actually happening when we start? So when we build a causal set, we define the rules for the causal set, how it's going to progress and evolve, and then we sort of have a generator system. Like, the way that causal set theorists you do it is typically with a Poisson style distribution sprinkling of events. So like, you just shoot in some random dots into the graph until they're close enough to each other that they can technically synchronize, and then the graph math says they synchronize. And once you've got a synchronized cluster that's stable, the system evolves forward, right? Or whatever direction it's being pressured in, which ultimately is the deep part of the mystery of what we call time. But I don't want to get ahead of us again, so go ahead. I think we all understand now what a causal set is. The four-dimensional part, that's the interesting thing, right? As it turns out, at a certain coordination coefficient, that 13.81 number we talked about, when you set that as a sort of anchoring parameter to say that a neighborhood of potentially related events has to fall inside of this log space region, this neighborhood, right? That's how you define whether or not there's a chance they can link together as causally related. But outside of that, there is no causation, right? Because they're too far away from one another. You can think about it like this: how loud can you shout and somebody can hear you from where you're sitting right now, right? If you at the top of your lungs said, "Anybody who can hear me, come here and I'll give you $1 million," you know, and you just say that over and over again, how long would it take before somebody came running from 5 blocks away? It would not happen, not unless somebody heard from somebody else, right?
Yeah.
They saw
Maybe your neighbors might hear you screaming and hollering,
right,
but
and call their
don't have
family
to.
member
Yeah. And
across
maybe
town.
call their family member. Yeah. Or maybe
Right,
they
which
just call the
means
police and saying this nut job's yelling that he'll give $1 million if you can hear me.
right. And this is weird too, because if you do, when you think about, making that shout, right, and then your neighbor hears it and they call somebody in a neighboring city, like
Mm-hmm.
we'll change the scenario a little bit. Anyone who comes here at noon tomorrow can have $1 million, and you're saying it from a really nice house. People call everybody. The grain changes on the synchronized cluster. You can zoom out and maintain a neighborhood. Right?
Yeah.
The neighborhood size cannot change. You can see that all the time, right? Like you're
Yeah.
looking at an ant on the counter with your naked eye, and then you put a magnifying glass between you and the ant, and all of a sudden the ant looks like it's bigger and closer. You just change the level of detail you can see by increasing the fineness of the grain on your observation frame. Right, so the neighborhood is flexible. It only fixes one axis. You can still zoom in and zoom out and maintain its consistency. That's really the point. But the 4D part is apparently when you do this every time, right? And this is the thing that blew my mind. That number results in the stabilization of a 4D reality under graph. Say 4D as in 3 plus 1, right? 3 physical spatial dimensions plus time, or the experience of time. What we call time. 4D Minkowski manifolds emerge from causal sets bound by the rules we just described, right? Literally, the universe we have falls out of graphs when you set that coefficient. That's all that means.
So it's basically expanding the telephone game, but stabilizing it.
It's a way to generatively evolve a 4-dimensional space.
Interesting.
Yeah, so you start with a sprinkle of random events, make sure to set the rule to that 13.18 neighborhood number, 81 neighborhood number, generate the graph forward, and voila, out pops 4-dimensional space and time, like 4-dimensional space-time, what we call that. And I don't like those words myself anymore after getting as deep into chronotopology as I have, but I'm going to use colloquial terms for a while until we get to the place where we can start talking about this in purely continuation geometric terms. But none of us are there yet, probably but me. And I'm still right on the very verges of being able to talk about it and not jump back to the old metaphors, So for instance, you keep tracking here, and eventually you will come to a place where you can think about time as not a thing that you move in, but as the experience of generating synchronization while continuing over time, or continuing over evolution, right? You evolve from moment to moment of events. The event is the primitive. Time is the perception of its flow. So, you kind of sort of you change the pride of place of time and replace it with causality, and you start to get the picture. But inhabiting that frame naturally is difficult. So,
because we think on parameters of what we can observe directly, and we're not gaining the actual bigger picture when we're thinking on a simpler measure. We've been trained
for years and years to think of time as fundamental and universal, and space as this immutable physical realm that we live in, and distance as how far, right? As it really turns out, that's not what's going on, but that's how we've learned to describe it. And so that's why Einstein, for instance, called time the most stubborn illusion. Right?
Rather than thinking infinite, we think universal. Not to say that universal can extend to the infinite, but it doesn't, because it stacks it into a finite expression of a small scale universality, to where you now have to explain it away in a linear format of what time is expressed on one end of the world to the other end of the world. But
everybody has a distinct now is the weird part. And the weirder part is that distinct now is not at all the same as everybody else's. And it's happening not in some sequence that's hard to determine, but in no sequence at all. Right? There's a lot of parallel event activity going on. and commensurating one to another requires synchronizing them. So you can't synchronize unsynchronized clusters and then measure them and say you knew anything about their state before you combined them, right? So you can't even really know simultaneity. It just doesn't exist as a concept. It's something we invented because we're finite. We live in particular moments, you know, and that's the hard part of abandoning the illusion of time. So I invite all of you to join me in trying to recognize where that stubborn illusion is influencing the way that you think about life, because it is an illusion and it will mislead you into making choices that that feel smart and that would be smart if you were thinking about the universe the way it really is, but will in fact lead you down a path to more stress and more anxiety, right, and more suffering. People the unhappiest people on earth are the people who assume that the universe is correct to my watch and everybody else is not on time.
Yeah. And on a theological perspective, just think of it this way: for the fallen ones, the angels who fell, who rejected God and were sent out of the kingdom to the earth, and hell awaits them. They rejected in the infinite realm of what we can't perceive as time, because we, being finite creatures living in time, we actually see time as more illusionary than what it is in reality. Time is a now in the eternal. So what is time? And so that you can kind of explain, like, well, the reason the angels that fell were disciplined to the extent of what they had done in their rejection, in their sin, is because they did it in the eternal. And so there is no expression of past, present, or future. They did it now. And so they're done. They're toast. They can't come back from their choice. Whereas we, being in the finite realm, can come back from our choice. Ever heard of the term repent? We have a journey to figure out how do we get to the better alternative.
See, and Zach, I got to point one thing out, and this is not to be mean. This is to teach the audience, and to hopefully reinforce my own reframing of this. The stubborn illusion caught you there. Do you remember where?
I do not know. I was just talking.
Anytime a person says in time, a person should give themselves pause and recognize that time is not a thing we're in, right? It's a thing we make.
Yeah.
And that's the only reason I pointed out, because it's very easy. I say it all the time still too, right? I just said it. I just fell into it all the time. Yeah. I just implied a single monolithic global time in that statement. Yeah. And I did not even just a single monolithic global time, but a single monolithic global time that exists independent of observers making measurements. And really what it is the act of measurement is what an observer does to make time.
And what is measurement, honestly? Like, but
measurement is
of our perception.
Measurement is an irreversible making of distinguishability, right? You look at something and you go, it's either this or that or the other, and then you make the measurement, and you know what it is, right? Yep. The making of the measurement required you to examine and synchronize distinctions that you hadn't previously made, right? Because before you make the measurement, you don't know how many feet it is to the door, right? After you make that measurement, you know how many feet it is to the door. And that number is never going to change. And moreover, it's going to anchor itself in your mind in such a way that you will have a hard time thinking about distance, not in terms of feet. From the first time you use that measurement system and get some results on. So measurement itself synchronizes a world, and we've come so accustomed to the observations we've made in our own that we've come to think of measuring as a thing we do to an objective outside reality, when in reality, the objective outside reality is what we made by measuring.
The key word here is perception, everybody.
Yep.
Perception.
Anyway, we should go on. Yeah, perception.
This is not yet a
We're not making reality. We're perceiving.
Mhm.
Our perception is being made. That's a very clear, good clarification.
Yes. All right. Shall we play?
Claim about every conceivable projection. It is a claim about the familiar physical chart. Inside that chart, the paper considers interval count operators. These count how many causal intervals of various small sizes exist. Not arbitrary patterns, not decorative statistics. Local interval structure. Then it asks, if you write down the most general, local, covariant, continuum consistent quadratic action in this regime, what survives the fluctuation law? That is the setup. Part 4.
Okay, there's a good pause. There's a good pause
The
right here.
surprise in the fluctuation.
So the idea is this, really simple. We're going to set up, and Thor is getting to say this is probably the cutest anyone's ever delivered chronotopology. But but the usual game that we're playing with this kind of measurement is first we set up the simulated universe, right? The causal set theory stuff we talked about earlier. And then we run it. And we run it with different, what they call covariant quadratic actions, which is just a way of saying this is how you plot the effects of causes in a four-dimensional manifold-like space-time assembly, right? Which is what emerges when you run the causal set, right? Happens to map to what we have in reality. Now we're going to check to see if the way that we've calculated our reality from different equations lines up with what we're seeing in the causal set. And if the way that they took it is, wow, when you do this, you get all the stuff that seems to be like Einsteinian relativity and Newtonian classical motion, all this other stuff just seems to fall out. Wow. And I said, well, what parts don't survive? And that was the difference between what I said and what the causal set theorist said, because I started looking at aspects of science through this lens that seem to claim causality is busted, that cause and effect can be mutated in a way that somehow breaks them and makes things acausal. Time-like paradoxes are really causality-like paradoxes. So when you think about like meeting your past self, right, that is an event stream of cause and effect relationships, the way chronotopology sees it. And you could hypothetically set that up without breaking causality. You can imagine that chain of events not being acausal, right? So you can at least tell a filmic story about a technology that allows you to do that, even though the building of that technology would require discovering a way to violate causality, which is why you can't time travel. In that sense, right? Like we could still set up a thing that felt a lot like time travel if we could remember past states and reset them perfectly in the future. But that wouldn't make it the past. It would just make it a future that looked a lot like a past state you remember. Right.
So honestly, come to think about it, like I think Star Trek kind of with their temporal like shifts in space and time, they kind of make that they make that relevancy in many of their episodes. Like the past really isn't the past; it's just another realm that they end up venturing into,
right.
And they don't. I mean, it's distinguishable to their perception of what's going on, and it can be altered to a certain extent within that time frame, within that timeline. Like it's a timeline within the essence of the now, rather than an actual time traveling between different time frames within dimensions of the universe. So like you're not actually going back in time, you're hitting a rift that ends up going into another realm effectively. So like another dimension.
Right. It's an entire new, the way that you would say it chronotopologically is you've entered a new stable basin that spectrally maps or tomographically maps closely to a prior basin that you were in. You're not moving back to the past. You're moving forward to a new future that looks indistinguishable from the past you were in previously, except for the fact that you remember being there before, which makes it different.
Yeah.
You're not time traveling because you can't forget that you've been there before.
Mm-hmm.
Right. Anyway, so let's. I wanted to make that clear. Because what we're doing here is showing how, with this harsh filter test, what math that we claimed to be fundamental to the universe survives at all. What's real, what's fake. You can use this as a filter for that if you trust that a 4D causal manifold that reproduces physical theories by default also precludes some physical theories by default. You can systematically march the sciences and find out which things actually still fit if causality is inviolable. And that was the whole effort of the chronotopological project. So anyway, that's what we're talking about right there when we say we're going to see what survives the fluctuation.
All right.
Paper 4 leans on something discovered earlier. In the synchronized subcauset regime, one fluctuation sector dominates, the nearest neighbor link sector. That does not mean links are the primitive stuff of reality. The paper is careful about that. It means the physical projection compresses closure cost in such a way that the dominant logarithmic fluctuation mode is carried there. That is a statement about projection, not ontology. The covariant structure becomes effectively rank 1. One non-degenerate direction, everything else bounded. That is the knife edge result. Because once the fluctuation structure becomes that sharply organized, uniqueness becomes possible. Part 5. Why BDG emerges uniquely.
Why uniqueness matters. Because uniqueness says more than just this causal set theory generates Einsteinian relativity. It says Einsteinian relativity is the unique only thing it could generate. There's nothing else, right? Humanity got it right, not because there were lots of options and it found one of the good ones, right? Humanity got it right because it was the only one to find. That's the statement anyway.
So essentially, the uniqueness is out of a confluence of many different possibilities. Say universes, like go into a multiverse type of theory. There's one unique sector that could be where humanity got it right.
Right. Yeah. And what we're about to go into is why in this particular domain, because the first thing I had to prove was that the action, the recording system that you use in causal set theory actually lines up as the uniquely correct action to get to a 4D manifold, because otherwise there could be other correct actions that yield different results on all of the rest of physics, right? So the first thing we had to prove was that the way that this graph theory works can only work this way. And that's what this paper's about. Anyway.
This is where I go into conflict with my Star Trek fandom. I think that the Taran Empire is the correct timeline.
Yep.
The Federation is fake, gay, and retarded.
I guess y'all are going to have to get used to living and let living, because the two can exist in parallel without interrupting one another. Then they're both valid.
That's always what made me intrigued about that timeline scope that they explored with Star Trek, is when they jumped into the Emperor Tiberius reign and the Taran Empire, and how different United Earth, as it expanded to the stars, ended up becoming. They became more aggressive and became more of a conqueror, whereas the United Earth, within the timeline that the initial series is within, is held to the standard of cooperation and expanding into alliances and trade apparatus. So one led to a United Nations type deal, the United Federation of Planets, and then the other led to a conquest of the Taran or Earth Empire, no different from the Romulans and the Klingons.
Right, which is a fun fiction, but it also not to pour water all over people who hope that someday the universe can be like Star Trek in terms of the political intrigue. Because if that's your favorite part of Star Trek, then you're going to be disappointed in the future. But if your favorite part's the exploration, then you're going to be okay, right?
Oh yeah.
Because ultimately, like that wow signal stuff we were talking about earlier,
Mm-hmm.
the origin of that signal can be approximated both in what we call space, which we'll learn later is really kind of a consequence of energy balance in terms of the parts of it that seem what we call empty and the parts of it that we consider full of stuff, right? Vacuum, what is it versus Earth, right? That doesn't have vacuum. It's actually pretty simple when you get down into it, but we got to put some building blocks in place before we can see how simple it is. Right. The point being that wow signal would have required not just a civilization's strength, but a long-term project of a civilization's strength in order to emit one time. And even then, you can't violate the rate at which that signal can propagate by sending the signal harder, right? There's no volume you can turn up to make light move faster. So trying to coordinate an empire across vast spatial differences like that, when you think about the local cause and effect relationships going on those planets, right? You all heard about time debt, like you travel really fast to a different distant star and you might experience 10 minutes of flight time, but outside of your little bubble of transit, cause and effect is taking place at its normal speed. And so that 10 minutes of you moving really fast across vast distances on the places that you left, the place that you left and the place you're headed to, who are not moving that fast because you're paying the cost to travel between them, right? They're having cause and effect flow at the rate that it flows locally on its own, right? So imagine trying to coordinate an empire where sometimes light takes 1 million years to go from one star system to another, right? And locally, it will feel like 1 million years pass before you get a signal back on what the bureaucracy wants you to do next in your government. You can't run a space empire. Physics does not allow it.
You really can't.
Anyway, the one thing that we will not have in the future is vast space empires because they will collapse waiting for instructions.
It's like all empires. Eventually they collapse because they're awaiting instructions to continue on.
Right, and really fast spaceships doesn't fix it because couriers can experience 10 minutes of ship time just fine, right? But no matter what, cause and effect is going to continue to flow where you're headed, where you came from. So by the time you spend 10 minutes on a really fast ship, and those 10 minutes to true up to where you're headed means, maybe 100 years, maybe 10 years, even if it's a closed star, 5 years, right? Is 5 years too long to wait for the next instruction from the central government about how to run your space? Yeah, it is. By the time those messages would coordinate with any empire when they're having trouble, it would collapse. Guaranteed, right?
Yeah.
Imagine if it took 10 years for a command from DC to reach the feds on the other side of the country. And what would happen in those 10 years while they were waiting for an instruction?
That's where Star Trek is great, a great fantasy fictional idea to kind of just explore your curiosity, but it was just it's really just Gene Roddenberry exploring the cultural and political phenomena of the day through the lens of sci-fi. But in reality, if you really wanted a fictional movie to kind of explore Interstellar, the Matthew McConaughey picture is actually probably the better
it's a lot
vision.
Closer, yeah.
It's a lot closer to the reality of what interstellar time travel would be all about, which is effectively expanding outside of time to what time really is.
Dude, The Martian really illustrates this point too, I just realized.
The Martian too. That's another good one.
Because think about it. Like the whole thing is about, well, we found out he's alive. Now we have to go get him. Right?
Yeah.
And so they're trying to coordinate with Mark Watney across just the distance between Earth and Mars. And because signals take, like 8 minutes to get from here to there or whatever, one way, 16-minute round trip on a conversation. That was a problem they had to physically solve with what we pointed out as hexadecimals earlier. Right? They needed more range of of bandwidth in their communication, but it couldn't be heavy bandwidth because it was already heavily constrained by the distance. And that's just Earth and Mars. Try to imagine the same story happening on Earth and a moon of Saturn or something. You couldn't even tell the story. Mark Watney would be dead if they left him, and he had no way to get local food. It would just been over. The transit time would have killed it. Right? And that story is only intelligible at the distance of about Mars.
That's and that's the interesting part of the two perspectives of those movies. One is telling the story of the outside from the perspective of one who is on Mars, and the lack of the bandwidth that we've expanded towards, and then the other is the story of what is going on Earth, and the difference between that space-time continuum within space because of the travel aspect. So, I mean, they're two different types of movies with two different types of stories that kind of explain away the same thing, but from two different perceptions.
Firefly kind of got it right too.
Firefly is just amazing, and I hear that they might bring that back.
They're bringing it back. It's going to be animated, apparently.
Yeah, it's going to be animated because they've all got
all the original voice actors.
Yep.
Cool, isn't it? I still feel like they should have done it like the way that you could have, with just like let the actors age and tell the story of what happens to the Firefly crew that many years later.
They should have done that, but they want to go off. I think they want to go off of where they last ended.
The setup would have been so cool because they could have literally done like the scene from the end of Serenity, where what was that? Right? The ship could land. You don't show anybody's faces. You just see the Serenity hitting turf. The thing drops and out pops Mal, aged to the appropriate age. And all of a sudden you've got all these stories to tell. Actually, the coolest way to do it probably would be like a mix of animation from the stories in between when they were younger and the real life when they were older. That'd be a cool way to do it. Anyway, I digress. Let's get back into the actual science instead of science fiction.
No, all right.
The paper then identifies the unique dominant direction. It coincides with the Benincasa-Dowker-Glaser coefficient vector. That is the technical heart of the paper. What it means in plain language. Props to those
scientists, man. Thank you for showing me the way.
Among all local quadratic interval actions compatible with the four-dimensional manifold-like regime, only one aligns with the logarithmic fluctuation law and the correct continuum limit. That one is the BDG action. This is a uniqueness result, not because the paper declared it so, because the fluctuation structure leaves only one viable eigendirection. That is extremely strong. It means the familiar gravitational action form in this projection is not arbitrary. It is forced by the live fluctuation structure of the regime. Part 6. What the action is not. Now comes the philosophical correction. The action is not the generator of motion. Paper 4 says this explicitly. Admissible motion is determined by continuation geometry and headroom. Action comes later. It evaluates the closure cost of the path that was actually realized. This is one of the cleanest reversals in the canon. Usually one is taught, first comes the action, then comes the path. Paper 4 says, first comes admissibility, then comes selection. Then the action records what it costs to keep that realized continuation coherent. That is a total inversion of the standard pedagogical instinct, and it fits beautifully with everything already built. Part 7. Closure cost density. To make that concrete, the paper introduces local closure cost density. This is the amount of residual burden required to preserve admissibility at each location. then the continuum action becomes the integral of that closure cost density. In the discrete physical chart, that ledger becomes the BDG action. This is the exact point where the paper becomes conceptually luminous. Curvature is no longer a primitive idol. Action is no longer a magic generator. Both become records. The action is what the regime writes down about the cost of having remained coherent. That is a stunningly clean reinterpretation. Part 8. Least action reinterpreted.
Whoop.
I'm actually going to pause that at that point.
Cool. I real quick before you say that, I want to real quickly just give a quick shout out to my good friends I've never met, Faye Dowker in Imperial College London, Lisa Glazer at the University of Vienna in Austria, and Dianici Benincasa at the Dublin Institute for Advanced Studies in Ireland. You, sir, and your two female compatriots are three people who I owe a great deal of debt for the work that you've done. And thank you, if you ever hear this, for pioneering the things that made discovering this possible. Anyway, go ahead.
The essence of this, I think, let's dive into what the blockchain has to do with what you're referring to right here, because I mean the action required is recorded, and I think that's where the blockchain effectively, it's the ledger that records everything that we admit, all the and the causal and effect that occurs within space and time.
Yep.
Whether digital, whether reality, we can use it as a tool. So you can do the same thing with AI. Like that's what technology has embraced us if we use it right.
Exactly. Well, and a lot of what people record in their minds as things that are happening are really recordations of things that are happening, right? Like when you think about what you experience it in real time, and you can't describe it until you actually take some time to describe it, which requires you to refer back to it somehow, right? So really, when we talk about the action, we're talking about like what our brains are doing. We're recording the thing post hoc so that we can make sense of it later in a sequence of cause and effect. And I think that's what you're pointing out with blockchains. And if you're especially astute, anybody watching out there, I'm pretty sure you probably already picked up on this, Zach. The one mistake blockchains are making right now architecturally ought to be becoming apparent, right? Because the system itself makes the same error that Einstein talked about as the most stubborn illusion. One linear global monolithic time, right? If you can imagine a blockchain with a head revision that includes parallel, unrelated chains of events to the breadth of reality, then you're looking at something a lot more like the ledger we're talking about here, if it were a real thing outside of our brains, right? The action itself is a bookkeeping method that we invented to keep track of a particular frame of reality. Right? It is not the whoop and wharf of it itself, so to speak, right? It is just what humans do to make sense of it. So that's what we're talking about. And one of the weird inversions of physics is they got so close to the math that they started thinking about it as the mover as opposed to the recordation of the movement.
So how would we invert blockchain to establish a ledger that is more outside of physics in the realm of physics?
If you might have guessed that far, then what you've probably guessed is that blockchain probably owes a lot to those scientists I nodded to right at the beginning of our little pause here as well, because that action itself is a firm denominated math equation that if you reduce to code can organize any kind of recordation graph that we decide to point out, right? So their software for studying causal set theory and blockchain software that takes advantage of the notion of parallelism and exploits, the unmasking of the illusion of time. That system could be very well built by this same equation. And actually, anybody who wants to can go, we've played with it earlier, but can go check out my code pens and see some of these maths actually running in a cheap little browser instance, little HTML and CSS and JavaScript on a site designed for experiments in visualization. Like cheap UI tricks is what most people use it for. But you can go over to my my code pen. I think it's codepen.io and /design heretic, and you can see experiments that use this action to draw visualizations. So anyway, that was the point. But yeah, blockchains can be organized around it very easily. One of the things I'm working on is writing up a spec for such a well, I call it a DAG chain or causal DAG chain, but it's short for directed acyclic graph for people who don't know. Most people don't put a hard causality fix on a directed acyclic graph or think that they can maybe replace block height with it. But there's a hint for people who know engineering.
And speaking of such, real quick, speaking of CodePen.
Oh yeah, did you find the one that shows the graph drawing itself? That's pretty neat.
I found this one.
Looks a lot like the cosmic microwave background, doesn't it?
Mm-hmm. This is your universe using chronotopological theory.
It's weird how much it looks like stars in the night sky, doesn't it?
Mm-hmm. It does. It's painting the picture of the universe for what it probably really is, rather than our perception just looking up at the night sky on a clear night without light pollution.
Yep. Well, and the way it blurs together and fades out, like it starts to look like nebulas and starts to look like, and the coolest part about that, we talked about the Poisson sprinkling for events happening. That's what you see, those little new dots as they emerge. Those are just sprinkled in on a random distribution over the whole field. Events happening that when they bloom out over time, as they solidify into the background, become a harder part of that reality. And so it's the evolution of events in a chain that cause reality to feel continuous, which is interesting because you wouldn't think that, hard ticks, dot, space would ever expand into something that looks like a blur of clouds and fire and gas and it's all the stuff that we see when we look in a telescope.
So the universe just expanded.
Yeah. Well, I mean, the universe
is contracting.
The universe is expanding to fill the space of events. It's events that drive the expansion of space, as opposed to the expansion of space giving events more room to occur. Which we'll get into later. But we should slide into the video because we've still got about half of it.
All right.
The classical principle of least action is also corrected. Paper 4 does not throw it away. It rereads it. Least action now means minimize closure cost subject to continuation constraints. That is much more disciplined than the usual version. Low action paths are not chosen by nature because nature loves elegance. They are paths that preserve continuation efficiently. High action paths are not forbidden by taste. They carry too much unresolved closure burden. That is the right chronotopological reading. Action becomes bookkeeping, not command. Part 9. Effective continuability comes first. Paper 4 then ties action to a deeper live quantity, effective continuability. That quantity ranks carryable motion. It determines what directions are favored. It governs admissible motion. The action does not define it. The action records the closure cost of motion selected under it. That hierarchy matters. It means the action is subordinate to the live continuation structure, not above it. This keeps the theory from accidentally reifying its own ledger. A ledger is important, but it is not the life it records. Part 10. Why the link sector dominates. The paper then returns to the dominant link sector. Again, this is not an ontological claim. It is a statement about compression in the physical projection. The nearest neighbor sector dominates the logarithmic fluctuation growth. That means the physical chart compresses closure cost into that mode more than any other. This is what allows the uniqueness result. The BDG action is unique in this regime because the regime's fluctuation geometry forces the ledger to take that form. This is not arbitrary normalization. It is projection-specific necessity. Part 11. Plateaus and action density. The paper then places action inside plateau structure. A plateau is a regime where continuation width no longer meaningfully increases under admissible perturbation. Within such a plateau, action density is stable, the coordination constant is stable, and fluctuations remain bounded around a regime-specific structure. This is important because it tells you what a stable physical regime looks like from the action side. Not zero action, not frozen perfection. Stable closure bookkeeping. The ledger stays legible because the regime is still metabolizing its own burdens coherently. Part 12. Lift and discontinuous reconfiguration. Then comes the regime transition story. When local closure is no longer sufficient, headroom goes to zero, and no admissible local motion increases effective continuability. At that point,
Let's
the
pause right
system
here.
undergoes lift.
So a good way to think about this is if you fill up a cup, right? You can do this experiment on your home counter right now if you're willing to clean up afterwards. You can fill it up right to the brim and even a little bit, like you get that surface tension sort of bubble over the top of the glass if you carefully fill it all the way to the freaking top, right?
Mhm.
And there's a point where if you add one more drop of water, something has to give, right? But that something has to give happens not where the drop happens, but at the edge of the glass, right? So what you've done when you put that next drop in that causes more than one drop's worth to spill over the side, right, is trigger a little bit of a lift event where something that gave caused the entire surface of the top of the glass and the whole contents of the glass to reorganize in a way that pushed more of it out, right? So one local change, broad non-local effect. That's the idea.
Another experiment that you can do, and it's actually a good use of your time and your energy, is especially if you garden and have vegetables that you want to preserve for the next year, you can can. So you get yourself a canning pan, get yourself some mason jars, you seal it up really good and plop the mason jar into the water for, I don't know, I think it's like 20 seconds to a minute or something. Depends on what you're canning and how you're doing it. It's been a minute since I've canned, but
Right?
you take it out, you'll pull out your canned mason jar. It's sealed enough. You don't want to fully seal it. You'll sit it on the counter, and that same effect right there, as you wait a few moments, as the pressure builds, it'll end up popping and
Yep.
sealing. Yeah. So if you hear a pop, you fucked up because it means it's not sealed, and that's
Right.
that pressure rising up. and
Exactly.
basically escaping. Whereas if you do not hear, if you hear like an inverted pop, sometimes you may not. It may not be distinguishable. You'll notice that when you walk in, the can is pressed down. You didn't do anything.
Yep.
It's the pressure sucking itself like a vacuum into the can.
Yeah, essentially, what you've done is you've created a little chrono pump with it, right? Like the dissipation of what we call heat from that sealed system forces it into a regime of lower pressure than the outside of the sealed system, which then necessitates that the air outside of the sealed system pushes it down and seals it for you, right? Literally, the universe is doing the work, so nobody has to sit on top of the lid and wait for it to pickle.
Exactly. And if it didn't work, then I guess you have the pickles right now.
Right. Well, and if it didn't work, can you imagine civilization surviving? Because that understanding helped build food storage very early on in human civilization. It made it possible without refrigeration to keep food for times when you couldn't grow food. Right. That is the universe being leveraged appropriately for continuation and survival of a bigger system, right? So we can now start thinking about the basics of civilization, canning working as it does, as part of the support structure that makes a human society as we are today even possible to evolve causally, right? The fact that works is part of the reason we even exist.
And that's why the old ways will never die, because we still can.
Right, exactly. A real super advanced technological society would have like spaceports sitting next to agrarian fields, right? Like, that's another thing Firefly gets right, is like, you're not always in high tech land. Yeah, there's super high tech facilities, but you can go out to the farm still, right? Like, it's still there. We're never going to not need food. So something to think about as we go is like, if all of these systems didn't work exactly as they do, would it be possible for us to exist at all?
Exactly. See, we're learning, everybody.
Yeah, let's keep rocking. But wait.
The Closure family reorganized.
Yes, Greg?
I was just saying, but wait, there's more. It was poorly timed idiomatic joke.
New effective degrees of freedom appear. The action ledger itself is discontinuously reconfigured. That is a profound point. Large action variation is not merely noise. It is a sign that the regime itself is changing. The ledger is being rewritten because the regime it was recording is no longer enough. So the paper links action discontinuity directly to regime transition, not just to fluctuation. That is a major interpretive gain. Part 13, Curvature Reread. Now the paper goes after another sacred object, curvature. In the continuum limit, the BDG action matches the familiar Einstein-Hilbert form. But paper 4 refuses the naive reading. Curvature here is not a primitive geometric idol. It is the physical chart encoding of local closure cost density. That is a huge correction. It means space-time curvature is not the ultimate thing. It is the continuum record of what it costs, in this projection, to keep continuation admissible. Once again, the visible object is a ledger. The deeper reality is continuation and closure. Part 14. Why the uniqueness is projection specific. Paper 4 is also careful not to overclaim. The uniqueness statement is specific to the four-dimensional manifold-like physical chart, the discrete causal set representation, the active denominator, and the closure discipline. That means different stable projections may have different canonical ledger forms, different dominant fluctuation sectors, different effective coordination constants. This is important because it prevents the paper from collapsing into one more universalizing metaphysics. The result is strong, but it is local to a regime. That is precisely why it is believable. Part 15. Why this paper matters. Paper 4 does two things at once. First, it proves a uniqueness theorem for the gravitational action in the familiar physical regime. Second, and more deeply, it reinterprets what an action is. That second move may be even more important than the first, because once action becomes ledger instead of generator, an enormous amount of downstream confusion disappears. You no longer imagine equations of motion being caused by a symbolic functional. You understand the functional as a record of closure burden along realized motion. That is cleaner, stricter, more physical, and it binds action back to the live continuation geometry that the earlier papers already built. Part 16. Final compression. In the four-dimensional manifold-like physical regime, the dominant fluctuation structure picks out a unique quadratic interval action. That action is the BDG action. Its uniqueness comes from the regime's fluctuation law. Its meaning comes from closure bookkeeping. It is not the primitive driver of motion. It is the discrete closure ledger of realized admissible motion in this projection. That is the paper. And it makes the familiar gravitational action feel, for the first time, like something reality would actually allow. Shortest compression. The action does not tell reality what to do. It records what it cost reality to keep going. Hard compression. BDG is unique because the regime only has one dominant way to fluctuate. Margin line curvature is not the law. It is the bill.
There we have it. Made it to the end of the video.
It just abruptly ends like a cliffhanger.
Yeah, well, and the cool thing about this is, if anybody is especially astute, they've already caught on to what that highly favored direction that emerges from causality might just be, right? If beginnings and the next thing that those beginnings cause and the effects of that cause and the effects of that cause happen in one direction that's favored by the fluctuation law, and all of the rest of the directions are suppressed, it starts to look a lot like an arrow. You know, what is it that people describe as arrow-like all the time? Oh yeah, the arrow of time. Interesting, huh? This is maybe how you get emergent time from cause and effect.
Or for the arrow for Greg, I'm with stupid. My direction.
I don't know if I can believe in the idea of stupidity anymore, honestly. At least
honestly, we're all intelligent beings. Like we're all educated in our own right in some capacity. Like what is stupid? But just the simple complex idea of not using your brain to the fullest extent. So we're not there is no stupid really. It's just people.
Right. Well, stupid is more like a level of tolerance that one has for ambiguity, right? Like if you're willing to be seen as stupid, which you want to feel stupid, let me tell you, have this math fall out of a computer software experiment that you were doing for blockchain stuff. and then find yourself faced with the gravity of the aha moment of, whoa, this is actually probably how reality is coordinating itself based on what I'm seeing, where I'm sitting.
Mm-hmm.
What do I do with this? How do I make sense of the reason I'm sitting here talking to you about it, Zach, and sounding smart, as opposed to you having a lot of questions and trying to process it all.
Yeah.
I had a lot of questions and I tried to process it all. And that started last year, right?
Yeah.
I was astoundingly stupid before this when it first emerged. I was actually blown away by how much of the process of being able to tell people about what I'd found had to do with becoming less and less stupid about it myself, because I'd look at these phenomena and I'd go like, what the heck does this even mean? How does this fit together? Right. These papers were the result of attempting to fit that together. So literally the process of assembling them prepared me to talk about it. But once upon a time, I was just like everybody else facing this stuff, right?
Yeah.
Staring at the result, wondering what the hell it meant, and being confused as all get out every time it conflicted with something fundamental that I'd internalized about how reality was supposed to work, right? The process of unwinding all of those hidden assumptions that my brain made just to survive reality, given what I'd been told about it, and the thing that I was seeing, to make them commensurate, work together. That was the hard part. So you all are in this at the level that I was once in it with us right now. You too, Zach, you more than most, honestly. You call yourself stupid. And I say that was a nice humility gesture, my friend. I'm glad you're staying academically honest. Because the hardest part is the more you understand, the harder it is to say, I don't know.
Yeah, exactly. But what I'm learning, especially with the reading today, the fact is like, stupidity, that's an obstacle in our own mind, because when it comes to intelligence, it's all causal, right? So like I go back to, we educate ourselves into where we feel a humble comfort in how we're going to maintain and sustain our lives, our whole livelihood. So the effect to that causation would be, one person may be good with their hands. I mean, agricultural, trade, building, like these are all intellectual capacity within another framework. Some people are good with their mind philosophically, some scientifically within the realm of physics or chemistry. Like there's different aspects. Some people
mind labor and shovel labor are really the same thing physically at their root, right? Like you grab a shovel, you start digging a hole, you make a shape in the ground. You start having a thought, you start digging a hole, you make a shape in your brain, right? You're not exempt from physicality by thought.
Exactly.
Thought itself is a physical process, right? So so doing thought work is just really precise work with a really tiny shovel, right? The amount of energy it takes, if you're doing high level versions of it, is equivalent, right? I may not look like a guy who works out a lot, but I definitely have to consume a fair amount of calories in order to keep up the thinking, right? Like
exactly.
You are in the physical world even when you are imagining things. Your imagination is a physical process.
And just so you know, everybody, when you're working with this rather than this, you got to work out. But when you're working with these, the hands, you don't have to work out.
Comes for free, man. That's
why
I like gardening.
The workout. No, if you're working with your hands at the job, the workout, actually, you're making money for the workout. So
it's true. And when you get into the high level, I can tell you, and Zach can probably tell you because he's seen me when I'm not so pretty, right? Behind the scenes when I'm not on the air. Doing this kind of work at this level will take it the hell out of you. Like you will actually feel it. I will get to the end of a day of working on this stuff and be exhausted, bone dead exhausted. And Zach's probably found the same thing working on his work. because writing is an especially heavy duty craftsmanship exercise when you care about doing it at a high level. So
I think that's why they say that when it comes to Sunday, if you worked with your mind, rest your brain, and work and go out and do some physical labor and work with your hands.
Which I'm going to do right now, right? Because I have been on this screen talking to you guys about something really complex, and I need to process. So I think it would be good for all of us if we all went outside and did some stuff. Myself and Glenn be the first person to take that advice. I'm going to be hands deep in dirt by the time everybody's watching the YouTube generated clips of this show.
That's what I need to probably do. I forgot to get I got so busy trying to figure out life and just the mundane that I forgot to start everything growth wise, seedling wise, prior to growth season. So I got to just go and just do the shortcut, man, and go get some veggies to plant.
The pressure on you for the future you're looking for is increasing. So causality will either force your hand, or you will live in a different future than the one you designed.
Exactly. So I suggest everybody, if you're going to garden, do it right and keep your seeds, which I do, and kind of and rehydrate them and grow them in order to be able to transplant them when it's time to transplant them in the ground. But luckily there's ways to shortcut it when you forget or just time gets away from you.
Right. Don't let the world make time for you. That's just your brain passively letting things evolve, right? And inaction is a kind of action. At least when an agent like you or me or Zach is deciding. So at that, I'm going to go out and dig in the dirt. Zach, I don't have time to hang out after the show because we ran a little long and I've got promises to keep. But yeah, I hope everybody has a really great Sunday, and we'll see y'all next week.
We'll see you all next week. Well, don't forget to like, subscribe,
and Sunday.
And hit that bell, and enjoy the Saturday and enjoy the Sunday, and get out there and touch grass, people. That's what I'm going to do. That's
Hands in the dirt, toes in the dirt, man. Garden without shoes on. That's the way to do it.
That is the way to do it, actually. So, and go ride a bike. I've been doing that recently too. It's awesome, actually. Let the wind touch your hair.
Breathe the air, smell the things. Your sense of smell is actually way more important than you might realize.
So, but with that, everybody, have a wonderful rest of your weekend, and we'll see you next week. And be sure to support for Andrew to get some hair plugs.
Right.
And possibly pay his work back for stealing that electricity, mining that Monero. Come on.
And don't snort Rogaine.
Don't snort Rogaine. Well, maybe if it works. If it works,
I guess if you need nose hair, then maybe snort Rogaine.
You can always use if you grow a bunch of nose hair, you could always gut it and then glue it on your head.
That's true. Hey, maybe we can take nose hair with donations.
So I can do it and see this bullshit right here. I could do the nose hair, snort the Rogaine. It grows the nostrils. I'll cut it and then just start pasting it. Make a beard.
Sounds like a way easier thing than yield farming, nose hair farming. Yeah.
So, but before we get too crazy, any last words, Greg?
Just everybody out there watching us, thank you, and we look forward to continuing in this. And I urge you all to believe in yourselves and recognize that stupidity is a bookkeeping artifact trying to keep you from not feeling stupid.
And with that, enjoy the wormhole you're about to go into, because there's some nasty little bug looking things that you may have to shoot.
Yep. Beep, beep. Pew, pew.
Peace, everybody.
Game saved.